Welcome to this explainer. Today, we're diving straight into the absolute science of DevOps automation to uncover what truly builds faster, more reliable software. If you've ever found yourself wondering what exactly separates just okay engineering teams from the truly elite ones, well, you are definitely in the right place. Let's get right into it. So here is the big question. Why on earth can some engineering teams deploy new features to their users every single day, sometimes multiple times a day, while others are stuck in these agonizing months-long release cycles? It's a massive gap in performance, right? And the truth is, it's not just about having smarter developers. It's actually all about the systems. For a lot of organizations, this becomes the ultimate engineering blind spot. They're writing more and more code, but somehow they're actually releasing less often. Why does that happen? Well, manual processes, a huge fear of breaking the production environment, and just a general lack of visibility, they all combine to create a giant bottleneck. The pain of failed deployments basically forces teams to slow down, batch everything up into these huge updates, and ultimately, it totally stifles innovation. Section 1. The DevOps Automation Engine, automating the pipeline. To fix those incredibly slow release cycles, we have to look under the hood at the actual mechanics of software delivery. The heart of this entire engine is the CI/CD pipeline. That stands for continuous integration and continuous delivery. You can think of this as a highly automated conveyor belt that takes code right from a developer's laptop and moves it straight to a live production environment. When you get this fully automated, it's a real game changer. It enables zero downtime deployments and practically removes human error from the release process. Let's break down how this actually flows in the real world. First off, a developer commits their code. Second, that action immediately triggers an automated build. Teams use real-world tools for this, like Jenkins, GitHub Actions, or GitLab CI. Third, the system automatically runs a whole suite of tests to ensure absolutely nothing is broken. And fourth, well, if everything passes, the code gets deployed. The automation handles all the heavy lifting, which means your engineers can actually focus on building cool features instead of stressing over messy manual releases. Section 2. The 4 DORA Metrics, measuring performance. Now, you might be wondering, how do we actually know if our automated engine is running smoothly or if it's sputtering? Enter the DORA Metrics. These were created by Google's DevOps research and assessment team. And these 4 specific indicators are exactly what the top tech companies use to separate the elite engineering teams from everyone else. We're looking at deployment frequency, lead time for changes, change failure rate, and mean time to recovery. Let's see what these actually tell us. Let's kick things off with deployment frequency. The elite performers out there, they are shipping code multiple times a day, literally every day. Now, contrast that with low performers, who might manage to push out one deployment every 6 months. The secret here is that the elite teams aren't shipping massive, super risky updates. Instead, they're shipping tiny, incremental changes constantly, which actually makes the whole system so much more stable. But hey, what happens when things do go wrong? Because let's face it, they absolutely will. That is where mean time to recovery, or MTTR, comes into play. Elite teams can recover from a failure in less than 1 hour. 1 hour. Low performers, it takes them anywhere from 1 week to an entire month just to restore service. That is weeks of agonizing downtime, lost revenue, and super frustrated customers, all because they don't have an automated recovery process in place. Section 3. Spotting bottlenecks. Finding the slowdowns. Okay, so we know the metrics, but how do we actually use them to fix our real-world problems? Well, by mapping these enterprise DORA metrics out visually over time, engineering managers can spot the exact bottlenecks choking up their pipeline. Say your lead time suddenly spikes. You know exactly where to start digging. Are code reviews taking way too long? Are your automated tests suddenly failing? Having this level of visibility lets you stop guessing and start actually fixing things. Now, the crucial point here is really understanding the nuance between these numbers. Take lead time versus cycle time, for example. Lead time is purely the customer's perspective. It's how long it takes from the exact moment they request a feature to the moment it's actually delivered into their hands. Cycle time, however, is the engineering perspective. That's the clock ticking from the developer's very first code commit until that code is live in production. Understanding the difference between the two tells you whether your real bottleneck is in the planning phase or in the coding phase. So, how do we speed all this up? We use Little's Law. This states that lead time equals cycle time multiplied by work in progress. Think of it like a busy coffee shop. If a single barista tries making 10 different drinks all at the exact same time, literally every single customer ends up waiting longer. It's the same in software. If you want to deliver faster, you have to actively limit your work in progress. Doing fewer things at once simply means everything gets done faster. Section 4, the AI productivity paradox. Faster coding, more risk. All right, now let's introduce a total wildcard that is actively disrupting all these well-established rules. Artificial intelligence. AI is everywhere in coding today, and it's generating code at absolute lightning speed. But recent data reveals something pretty shocking. Increasing AI adoption is actually causing a 7.2% drop in software delivery stability. No way, right? But yes, a literal reduction in stability. Let's break those numbers down a bit more. Sure, AI boosts code quality by 3.4% on an individual level. However, overall team throughput actually drops by 1.5%, and delivery stability takes that massive 7.2% plunge. Why on earth does this happen? Because AI allows developers to generate so much code so fast that it completely breaks the golden rule of DevOps, the small batch deployment. Suddenly, these massive, sprawling code changes get submitted, code reviews turn into overwhelming bottlenecks, and ultimately, things just break in production. AI definitely makes individuals faster, but it can easily clog up the entire team's pipeline. Section 5. Scaling delivery. High-performance teams. To manage crazy complexities like AI and huge organizational structures, we really need to adapt. For big enterprise-level organizations, just looking at a median average, that doesn't cut it anymore. When you track statistical variance in deployment frequency, wide bands represent a 10 to 90 percentile range. A super wide band means your process is completely unpredictable. A narrow band, though, means you have fantastic control. Looking at this data helps leaders quickly identify their absolute best performing components, harvest those good practices, and lend support to the teams that are lagging behind. Ultimately, all of this ties directly into your core business strategy. DOR targets should absolutely never be one size fits all. You have to customize them based on your product's specific investment intent. Look, if you're building a highly innovative new product, your main goal is fast time to market, right? So you naturally prioritize lead time and deployment frequency. But if you're sustaining a sensitive legacy banking app, your primary goal has to be quality and zero downtime. So you strictly prioritize a low change failure rate and a super rapid mean time to recovery. The metrics always have to serve the business outcome. So as we wrap things up today, I want to leave you with this provocative thought to chew on. How does your engineering team actually measure up? Are you operating as an elite performer, or are hidden bottlenecks and massive batch sizes quietly slowing you down? I highly encourage you to take a hard look at your own DORA metrics this week. If you found this explainer valuable and you want to keep optimizing your knowledge, please like, share, and subscribe for more explainers just like this. We'll see you next time for another deep dive. Keep learning and keep